at what time, um, and what is the position on the y where the velocity is 0. Okay, from part B, we found the velocity in the form of, which is the y prime, which is 30 times cosine of the t. The condition for this part E is the velocity is 0. So if we let 30 cosine t be 0, we are going to solve for t. That's what we're going to find out for what point of time that the velocity is 0. And to solve the trig function, just recall what you did back in trig or in pre-calc. Set it be 0 and then untangle it or find out what is the t or what is the angle t that make cosine to be 0. Okay, for our case here, cosine t equals 0, or where if you have the unit circle, somewhere like close by, so you can look it up. The cosine t is the x coordinate of the order pair xy. So the cosine t equals 0, or where the graph or the circle across the y-axis. So that means this one will give you at the point t equals pi over 2, 3 pi over 2, and then if you keep going, going to be 5 pi over 2, or keep going. That means you can write in the general form as pi over 2 plus the multiple and the multiple of the pi. That means if you add another pi on top of it, or you add another a half of the revolution, you're gonna hit another point that the cosine gonna be 0, or hit another y-intercept, basically, if you look at the graph of the unit circle. And if we see the graph that we just obtained, where the point that the velocity is 0, yes, we analyze it from using the original graph. You see that is at pi over 2, and over there at 3 pi over 2, 5 pi over 2, and so forth. That is the same set of the numbers that we got from doing analytic way. Okay, we got the t, and next we're gonna find the velocity. We're gonna find the position at those point of times. For example, if t equals pi over 2, the position, which is the y, the original y, gonna be 30 multiplied by the sine of pi over 2 minus 1, with the whole thing subtraction first before you multiply by 30. Sine of pi over 2, what would that be? That is 1. So 1 minus 1 is 0. So at the point pi over 2, the position is 0. How about the other number? Well, I'm going to need to make more room. Sorry about that. Okay, so this is for t equals pi over 2. How about t equals 3 pi over 2? The y is 30 times sine of 3 pi over 2 minus 1. So sine of 3 pi over 2, this is negative 1. Negative 1 minus 1, now it becomes negative 2. So negative 2 times 30, that is negative 60. It's kind of back and forth between value 0 and negative 60. So if we look at the graph that we just did, at pi over 2, the slope 0, 3 pi over 2, slope 0, and so forth. But for the position function, at the point pi over 2, the position is 0. At the point 3 pi over 2, the position is negative 60. And back to the position 0, back and forth between 0 and negative 60. Okay, they all come together. And next one, kind of the graph goes back and forth. That means the group of the pi over 2, and then skip 3 pi over 2. This is going to be the same as 5 pi over 2. And the next one going to be 9 pi over 2. So every revolution you hit the same point. Every revolution, or every 2 pi you hit the same point. Same set as when t equals 3 pi over 2. Another round, another revolution, or you go another 2 pi, you're gonna get the same position, which is negative 60. So another 2 pi from 3 pi over 4 is gonna be 7 pi over 2, 11 pi over 2, and so forth. So kind of you break them up into 2 sets of the point of times. One set of the point of time, the position gonna be 0. the other set of point of time, the position is at negative 60. That means in the downward position or in the direction that's going downward. Okay, negative means downward. And 0 means at the equilibrium position. Equilibrium. Okay, equilibrium position. All right, so, and then part F, at what times and position is the velocity a maximum? Velocity maximum, that means the V max occurs, that means what is the maximum value of the velocity? If we use the graph, I'm going to go back real quick. For the graph of the velocity right here, the maximum is, the velocity is 30, 30. The velocity we consider negative and positive sign. So the maximum, the Vmax equals 30. And when we look at the graph, at the original or the initial point of time, or when t equals 0, the velocity is at the maximum value, which is 30. And then since the graph is the graph of the cosine, it has the period of the 2 pi. So after 2 pi second time of the time, it comes back to the same position to reach another maximum of the velocity again, and then another 2 pi, which is at 4 pi, gonna get the V max again. Okay, and from here the V max equals 30, and the unit is centimeters per second. At what time? So we know that gonna be at the maximum at t equals 0, and the multiple of the 2 pi. So t equals 0, 2 pi, 4 pi, and so forth. Or we can rewrite it as a general form as 2 pi multiplied by n, or like as n is the integer, n is integer. But you can change the number n as n equals 1, n equals 2, n equals 3. So at those point of time, the velocity gonna be the maximum value, which is 30 centimeters per second. And looking for the position. Position, that means for the y equals 30 times sine t minus 1. At t equals 0, use the graph as a reference again. At t equals 0, the position is negative 30. At 2 pi, it comes back to the same position, same position, same position. So that means at those point of time, the y at those point of time is negative 30. Negative 30, the unit is in centimeters. The sign is negative, so that means in the downward position. Okay, in the downward position. Okay, at every same point of time, like every 2 pi, like from 0, 2 pi, 4 pi, and so forth, and it will reach the maximum velocity, and the position at those position, the position at the same maximum velocity is negative 30 centimeters, which is at the downward position from the equilibrium point, or from the starting point. And then part E, the acceleration of the oscillator is A of t equals V prime of t. We find the graph and the acceleration function from provided form here. Acceleration is the rate of change of the velocity, or the A equals V prime, and we already got V prime as 30 times cosine of t. So find the derivative with respect to t, because in our case, the t is the independent variable. But the derivative coefficient 30 or the constant multiple remain the same. Now we find the derivative of the function. It begins with a c, going to be negative. Cosine and sine, they are a pair. So not the x, sorry. So it's going to be t. And simplify to be a negative 30 times sine of t. Sine of t. This is the acceleration function based on the same position function. We got the function, and how about the graph? If we look at the graph, going to be the graph of the derivative of the v, or we can compare with the graph that directly from the function that we just derived from finding the derivative. So the sine, the typical sine function starting from 0 and up and down, but this is negative 30, or the negative A value, the amplitude is still 30, but the graph is reflected. So that it's going to be the flip side graph. Okay, instead of going up and down, going to be going down and up and down, something like this. So this should be the graph of the acceleration function. And the amplitude still 30, the lowest point at negative 30, maximum point at 30, and up and down, up and down. If we use a graph of the velocity again, at the point of time 0 here, the slope is 0. So we get the slope 0. Over here, the slope 0. Right here, the tangent is 0. At 3 pi, the slope is 0. So we locate the point 0 slope for the graph of the acceleration, which is the derivative graph. And between the first 0 and the second 0 here, the first horizontal tangent to the second horizontal tangent, the graph is decreasing. The graph decreasing. So the graph will be negative in value. And between the second tangent to the first tangent, to the third tangent, sorry, the graph is increasing. So the graph will be increasing and remain in a positive value and then go back to 0. And similar way, gonna go back to below a x-axis again because the graph is decreasing.